Hello everybody, we're in section R.7 and we're going to try to multiply and divide rational expressions. So the first thing we need is the definition of what a rational expression is. So let's get a definition. Okay, a rational expression is the quotient of two polynomials. Pretty fancy. All that means is you've got a division sign, you have one polynomial over another. So here's an example of a rational expression. 5x squared minus 17x over 3x to the 7th minus 40x to the 5th. This is a rational expression. Up top I've got a polynomial. It's two terms, it's degree 2. On the bottom I have another polynomial. It is also two terms in degree 7. Polynomial over polynomial. That's a rational expression. Okay, how do we multiply rational expressions? Let's take a look. Okay, to multiply two rational expressions, here's what you do. I've got a over b times c over d. I get ac over bd. And this rule should look very familiar. It's your fraction rule. It uses the same exact idea. Multiply tops together and the bottoms. It's pretty similar to fractions. So let's look at an example. Okay, directions will say something like form the operation simplify. And here's my problem. I've got x squared minus 2x plus 1 over x cubed plus x times 4x squared plus 4 over x squared plus x minus 2. Okay, when you're doing a problem like this, here I have a rational expression and another rational expression. Polynomial over polynomial, polynomial over polynomial, and you're multiplying. That's the operation. So step number 1 is factor the top and bottom of both rational expressions. So equals this top one, trinomial leading coefficient of 1. Look, two numbers, multiply to 1 and add to minus 2. It's going to be x minus 1 and x minus 1. Bottom left fraction, greatest common factor is x. I'm going to take an x out. Leaves me with x squared plus 1. Almost tempted to factor this like a difference in squares, but it's not. It's a sum of squares, so I know that doesn't factor. This first rational expression is all factored, so times, I haven't done the operation yet. Let's see, this one, I can take a 4 out of both. So take a 4 out, leaves me with x squared plus 1. On the bottom, another trinomial. So I've got a leading coefficient of 1, and I'm looking for two numbers. Multiply to minus 2 and add to 1, and that's going to give me x plus 2 and x minus 1. Now that everything's factored, the next thing you do is cancel out terms in common from the top and the bottom in a one-to-one fashion. So it's got to be top and bottom. It doesn't. You can go diagonal, that's fine. But things at the same level don't cancel out. So this x minus 1 and this x minus 1 don't cancel. But this one cancels out with this one in a one-to-one fashion. This x minus 1 doesn't get rid of all the x minus 1s on top. Just one-to-one. These guys have anything else in common? Yes. X squared plus 1s, they cancel out. Anything else? Nope. Then whatever's left on top stays on top. So I got 4 and x minus 1. And on the bottom, what's left? I got an x and x plus 2. Factor everything, cancel things out in a one-to-one fashion, top to bottom. Whatever is left is what you have. And that is how you multiply rational expressions. Let's try one more. Okay, let's try this one. Again, we're multiplying, and I have two rational expressions. So let's see if we can follow the 3 steps. So here, if you want to pause it and give it a shot on your own, go for it. I'm going to factor everything I see. So top left fraction, I can take a 3 out, which leaves me with x plus 2. The bottom is a single monomial. I can't factor that at all, but I don't lose it. I just rewrite it. I haven't multiplied yet. That sign seems the same. I have an x here, and at the bottom, this is our classic difference of two squares. Plus 2x minus 2. Now the fun thing, we get to cancel out stuff. X plus 2 and x plus 2. And this x takes away 1x in the bottom, so the power goes away. What's left upstairs? A 3. What's in the bottom? I still have a 5 and an x and an x minus 2. And we got it. And there's no magic teleporter, so whatever's stuck on the bottom is stuck on the bottom. You can't bring stuff up by magic. What is in the bottom stays in the bottom. Anything left to cancel out? Nope. We got ourselves our final answer. Okay, now that we've multiplied, the next thing to do is obviously to divide them. So to divide two rational expressions, here is a rule. So I have a over b divided by c over d. Well, it's the same as your fraction rule. Top fraction stays the same. The second one gets flipped. And then we're back to multiplication. This is AD over BC. And here we just have to be careful of the following things. B, C, and D cannot be 0, because that would cause division by 0. And that is something that is an undefined operation. So the good news is, if you can multiply rational expressions, you can divide them. You kind of get that for free. All you have to do is remember to flip the bottom one, and we're back to multiplication. So, but do that. So when you're doing these, flip first. That's the first thing you do. Then factor. Okay, let's take a look at an example. Okay, so perform the operation to simplify. Here's a rational expression. I got a polynomial over a polynomial, and I'm dividing by another rational expression. Remember, flip the bottom one first. So the first rational expression stays the same. I got an x squared plus 7x plus 12. Stays the same. I got x squared minus 7x plus 12. Multiplication turns into division turns into multiplication as long as you flip that second one. X squared minus 16 over x squared plus x minus 12. Okay, now I'm going to factor all the tops and all the bottoms. Here's a note. You can't cancel until you start factoring. So even though this is a 12 and this is a 12, you can't cancel them. They've got to be factored first. You need products in order to cancel out. So top left fraction. I got a trinomial leading coefficient of 1. Looking for two numbers to multiply 12 and add to 7. And positive 7. That's going to give me x plus 3 and x plus 4. Bottom left fraction, same deal. Two numbers multiply 12, add to minus 7. It's going to be x minus 3 and x minus 4. I think that'll work. Minus 3 times by minus 4 is the positive 12. And minus 3 plus minus 7 is going to be minus 7. I'm sorry. Minus 3 times plus minus 4 is going to be minus 7. Up top, difference of two squares. X plus 4, x minus 4. And on the bottom, another trinomial, leading coefficient of 1. Two numbers multiplied to minus 12, add to positive 1. That's going to be x plus 4 and x minus 3. Alright, now we cancel out top to bottom in a 1-to-1 fashion. This x minus 4 cancels out this one, and this x plus 4 cancels out this one. So what am I left with? Up top I've got x plus 3 and an x plus 4, and on the bottom I've got x minus 3 and another one. And on the bottom those are going to multiply together, so up top I got x plus 3, x plus 4. On the bottom I got x minus 3 squared. And that is my final answer. And that'll do it for this video. That is multiplying and dividing rational expressions.